All right, welcome everyone to this live stream. My name is Jardin and I will be your presenter today. And today's live stream is reading data from DeSo using APIs. I'm going to show you guys some great stuff on how to work with data on the DeSo blockchain. But I am going to also help those who are not, who don't know what the DeSo blockchain is. I will provide a quick introduction. This is a beginner's web live stream. It's for the beginners. Whether you're a beginner technical person or non-technical, you will definitely gain from this live stream. It was meant for you. If you find yourself more advanced and you've already had experience with integrating with APIs, you might not find this live stream too valuable. However, there's going to be a couple of topics that I'm pretty sure you might not just know unless you are really a developer on Web3 technologies and primarily the DeSo blockchain. So let's move next. We have the agenda, and the agenda is pretty basic. We're going to focus a little bit just to quickly understand what is the DeSo blockchain. We are going to then discuss APIs versus AUIs. We're going to do an introduction to web APIs, which is the type of integration we're going to be performing against the DeSo blockchain, and we're going to do some live demos where I'll show you in real time how we're going to query all kinds of APIs from the DeSo blockchain to return some crazy stuff that I'm sure you never thought you would be able to do, but by the end of the session, you're going to be able to go mad. You'll be able to start right after the session. That's how easy it is. There's no installations or anything on your machines required. This is really get up and going with the DeSo blockchain. So what is the DeSo blockchain? All right, so DeSo stands for Decentralized Social, and the blockchain is a layer 1 blockchain that stores all social media content types on the blockchain directly. Now, if you take a look at what we know from the Bitcoin blockchain or from Ethereum-based blockchains, the focus is to only really store transactional data, mostly financial. And but obviously on the Ethereum case, they allow you to store a little bit more information. But the cost of storing on the blockchain will depend on the size of the transaction that you are going to store. And people do their very best in order to store as little as possible on the chain. So when I say on the chain, it's on the entire blockchain that gets synchronized across all the computers, versus off-chain, which is on a central server. Because remember, the focus here with the blockchain is to decentralize the data, to have it spread across multiple computers on a secure chain where the data does not belong to any specific person, but just exists on the blockchain, open and transparent. So when we come back to Decentralized Social and the DeSo platform, they are really breaking through with innovation in terms of how they are storing all the social media data, whether it be posts, whether it be likes, whether it be comments, whether it be images, whether it be videos, your user profile, everything gets stored on the blockchain and it gets distributed across all the computers, and you are the owner of your data. Okay, you are the owner of all the data that you post. However, because it's on the blockchain, even though you are the owner, the data is open. Okay, it's open on the blockchain and it can be read by everyone. And you will see what I mean when we get into the live demonstrations, how we interact with the blockchain. So what's important to know about this is that your social graph is like a mind map where you are in the middle and you just have these maps to all kinds of things that you do on the social media platforms. And this is what they use in order to advertise and sell your data. And on the DeSo blockchain, they use that social graph, but they use it in reverse. It's open data, and it can be absorbed by anyone. So it's not isolated to a Twitter or a Facebook that they own the data, and now these advertisers come and pay big bucks so that they can understand what it is you do on a day-by-day basis. What are your likes? What is it you want? What is your desire? So that they can advertise and send you the right ads. So Twitter and Facebook and these companies, they use what you're doing so that they can make money off of these platforms. On the DeSo blockchain, it works the other way around. Everything is a transactional cost. So you ask yourself, how does DeSo make their money? Every transaction on the blockchain is a cost, but the cost is so small, it is actually laughable. Now, let's give you a quick example. Take the Ethereum blockchain. If you want to maybe send some Ethereum from one crypto wallet to another crypto wallet, even if it's $5, it's probably going to cost you $20 to send the $5 from one wallet to the other. But on the DeSo blockchain, if you post an article or if you post something on the feed, like for example, let's go ahead and I'm going to jump onto one of the platforms over here, and that you'll see it looks very, very similar to Twitter. And I'm going to just go here and I'm going to say, hi there, I am streaming live. This is a demo post. All right, I'm going to click on post. And there it is on the DeSo feed. Now, what a lot of you don't realize is that I just performed a blockchain transaction. This exists on the blockchain. I had to pay for that post to exist. But the cost of that post is around 0.00017 of a US cent. So this is the average cost per post. It would take you probably a year to reach an amount of spending about $1 to $2 for the content that you would land up posting on the blockchain. So this is seriously crazy. This is like next level innovation on the blockchain. Very, very exciting stuff. So we have, so there's no central authority. I think we are done with this slide. Now, DeSo is a focused blockchain for creating social apps. So how does this work? Let's move to this screen over here. This is the DeSo blockchain over here. We now know that the software runs on multiple computers that makes up the DeSo blockchain. We know that all data is stored. All data, images, posts, likes, trends, everything are stored on this blockchain. But what does that mean now? Does DeSo have an application like Facebook? Does DeSo have an application like Twitter? And the answer is no. They don't design the actual applications. They focus on the blockchain, the data, the security, and the architecture and controls that allow me as a developer to go and design my version of Twitter, to go and design my version of LinkedIn maybe. And that's exactly what exists right now on the DeSo blockchain. Just to give you a few examples, you can see over here, here's the blockchain. Here's examples of social media applications that are running and use the blockchain to store and retrieve data. But look at this user account in the middle. Does the user account, when you register on a social media platform, are you registering on their platform? No, you're not. You're registering on the blockchain. You're just doing it through their platform. So all data exists. Yeah, let's show you this in action. I'm now going to go back to this DeSocial world, which is one of the social platforms that are available that were developed by someone else, and all they do is they store everything on the DeSo blockchain. It looks very similar to Twitter. I can go over here and I can click on a like over there. I can even tip diamonds, by the way, because we're on a blockchain, because we're working with crypto, I can actually tip crypto to posts whenever I see a post that I would enjoy. So all of this is now on this platform. But if I go to my profile, let's go and see. Here's my user profile. Here's my bio, my picture, my user account. And if I go down to my posts, be very mindful. Look at the last two posts. The one that I submitted, hi, I'm streaming live. And the other one over here for beginners. And this was something that I posted recently as well. Now, I'm going to jump to another application called Overcloud. Now, this is a completely different social media application that was developed, and they focus a lot on analytical insight that is directly on your homepage. They give you stories that you can upload, which is very similar to Instagram, very similar to Facebook. And they do live streams as well, which is why we're streaming to their platform right now live. And they do articles very similar to medium.com. So they kind of similar to what we saw in DeSocial World, but they're offering other features and functionality. But what happens when I once again go to my feed? If I click here on Overcloud, notice that my user account is the same. Notice that my image, however pixelated, is also the same. And if you go... if I refresh this, this is this is pinned, but let's go down. Look at this. Hi there, I'm streaming live. This is a demo post, and I can go and you can see that what we've done over here is the content that I posted on this application exists on this application over here, and it can exist on other applications as well. And the reason for that, once again, is that the data exists on the blockchain and not per these social apps that have developed on top of the blockchain. And my user account also exists on the blockchain. So I don't have to keep on registering accounts with each of these platforms. Very, very crazy stuff. I'm going to stop it there, though. I'm going to leave it with that in terms of what is the DeSo blockchain. But I will give you links at the end, and you can also scan this QR code, which will take you to my DeSo Essentials course on my Web3 Simplified YouTube channel, which is over here. And you can see here are a number of videos already. And if you go to the playlist, there's a DeSo Essentials playlist on my Web3 Simplified, which will give you a lot deeper insight into how the blockchain works, how to get going with the DeSo blockchain, and a couple of the concepts to understand. Okay, so you got everything that you need over there, and we can move on to the next phase. Just stopping over here quickly. Something for the technical folk. Now that you understand what the DeSo blockchain is, in case the technical folk don't want to stay till the end and they just want to know how do they integrate and how do they get started, web APIs are all you need to build apps and integrate with the DeSo blockchain, okay? This is how you interface, whether you want to post transactions, whether you want to retrieve data, whether you want to create NFTs, whether you want to write applications. It's through web APIs and through their web API layer that you are allowed to do all of this. There is no Solidity. There is no sort of Ethereum-based means of interfacing with their blockchain. And just to give you a quick example, here is their documentation, docs.deso.org. And if I go here for developers, and if I go to user endpoints, notice it is web APIs all the way. All right, so what is an AUI? An AUI actually just stands for Application User Interface. It's also known as a GUI, which is a graphical user interface. Its short name is GUI. And you've got normal UI, which is just user interface, which is what we'll end up using for pretty much the rest of this live stream. We'll just call it UI. So an application user interface, what is this? It is any application or system that requires you to load a visual interface in order to interact with it. All right? So if I went over here and I wanted to post something on Twitter as an example, so I open up Twitter and I want to go inside because I actually want to post something on the Twitter feed. I have to open up a web browser. I have to go to this field over here and I have to type in the text and click on the tweet button, which will post the transaction onto Twitter's platform. So this is a good example of me accessing Twitter as an application via its user interface, application's user interface. All right, so that's what AUI is, and that's what we just regard as user interface. So examples of this are websites, like I showed you now, Twitter, but also Facebook, YouTube, any blogs like WordPress, your Gmail, when you go to gmail.com. These are examples of applications where you have to access and work on them using their user interfaces. All right, desktop apps, you're looking at your Microsoft Office stack, which is your Excel, Word, your Outlook. You're looking at your Photos app or your PDF reader. These are installed on your operating system, but they still require you to open up some sort of interface in order to perform a task on those on those applications. And then finally, mobile apps, another great example. Clubhouse, Twitter, your contacts, even YouTube, even you having to go and call someone. In order to call someone on your smartphone, you have to open up the phone application, and you have to interact with it in order to perform that call to phone whoever you want to phone. So these are basically just quick examples of an application user interface. I'm trying, I hope I'm not dumbing it down too much, but it's very important because it justifies, when we get to API, it justifies the differences between the two. So just quickly, benefits of user interfaces. It simplifies interaction with data and call to action. It's so easy for me to go onto a Twitter to read data. Everything is so well structured. Twitter's doing a great job to give me the information that I need in order to perform the tasks that I want to perform. It's brilliant. Okay, that's a great benefit of working with a user interface. The other one is that it creates a rewarding user experience. And I can, it's depending on like Instagram, the feeds, the way everything works together. It's wonderful to work with, and I can use it on my mobile. I can use it on the desktop. I can use it on the browser. It all just works great. Okay. So let's go to the next one now. What are the cons of actually going and accessing Twitter on a user interface? Well, it depends on how technical you want to get, but we are going to be taking the next step. Even if we're non-techies, we're going to be taking the next step over here so that we can focus on some nice stuff. And to understand the cons of the user interface is very important over here, because it's, number one, we're looking at limited functionality. All right, limited functionality. An application can usually perform way more operations than what is allowed via user interface. Just because Twitter's allowing me to click on here and tweet and comment and like doesn't mean that's all it can do. It can actually do a lot more, but that's what it's exposing to me as a user, because it's enough for me as a user to do what I need to do. But if the moment I wanted to get maybe a little bit more advanced, then I don't have access to some of those advanced features which are potentially available. All right. So that's what I mean by limited functionality. The second one is limited data. The amount of data seen via an application's UI is usually a subset of the total data that exists. Coming back, we're gonna pick on Twitter today. Coming back to Twitter, just because this is the data that I'm seeing right here on my user interface, whether I go to these various sections, that doesn't mean that that's the data. If I look at this post over here, you won't believe it, but it looks as if there's only like a couple of things: the post itself, who it's from, and the amount of comments, and a couple of other things over here. But what you're not seeing is a number of additional properties that makes up that post that can provide you crazy insights into when it got posted, from maybe where it got posted, and a number of other things that you could really get analytical about. And you won't be able to retrieve that data here on the interface. Then you would have to go via different means. And finally, limited integration and automation. Other solutions cannot integrate with an application that only has a user interface. Now, right now, I know for a fact that Twitter has APIs. Okay, I know that. But can you imagine if I wanted to go, I'm using Canva right now. I'm using Canva, and this presentation, I've got a share feature on top here. And if I want to share, I can click on the share on social and look at what one of the options are, Twitter. Now, if Twitter never had APIs, I wouldn't be able to perform this. Okay, so we're going to get to that now, and I'm jumping the gun just slightly, but bear with me. All of this is just going to come together and make a lot of sense. So now let's understand what is an API. When an AUI stood for Application User Interface, an API stands for Application Programming Interface, the ability to perform transactions against an application without accessing its user interface. What if I was allowed to go into a notepad and post a tweet from my notepad without even opening up Twitter's website? That is now an example of me posting that tweet, that text via an API layer, which is Twitter's. And they basically allow me, without me having to open up Twitter's website, they allow me to post a tweet and it will show up right here. And this is exactly what Canva's doing. When I click on share and I go to share on social and I click on Twitter, they are interfacing. There we go. Look at there. There's my Twitter account. They accessed Twitter's APIs, which allowed them to do it programmatically behind the scenes, no interface required. It went and fetched access for me and went and fetched my profile info, which it loaded over here, and it is now ready for me to actually post something to Twitter, in this case, this presentation. So this is what an API is. Examples of this. A great example is Siri on an iPhone, or Google Assistant, or Alexa. Every time you ask Siri something, or Google Assistant, every time you want to know what time is it, or what this calculation is, or when this occurred, or search this for me, or book me this, or send me a reminder, you are speaking to a system that accepts the speech in audio format, converts it into text format, uses AI in order to understand what you really asked it, and then just starts calling APIs in order to return the result to you. Okay? If you said, please show me, or please tell me what my latest post is on Twitter, and it goes and says, your latest post is this on Twitter, it's not because Siri had it. Siri called Twitter's API in order to fetch it. Okay? Very important that you understand now the difference between having to go onto a user interface versus doing things behind the scenes. using APIs. Uber uses Google Maps. How do you think? Do you think Uber would go and redesign the map engine that Google spent so many years on? Google provided their Maps object or their Maps engine using APIs. Anyone on the mobile or on the web will be able to interface with Google's Maps and be able to do plotting and directions and navigations and geolocations. None of that, you don't have to develop that anymore for your own applications. Google's got it for you. They make their money in their own ways, and you don't have to spend years trying to build something that already exists and is already available to you. And why? Because there are APIs. And then finally, if you take a look at logins, if you want to go onto like a certain platform and you want to log in, and this, like I go to Reddit over here. Let's open up Firefox and let me go to Reddit, reddit.com. All right, so let's go to reddit.com. And I want to go inside there and I want to start using Reddit. Now I can sign up. So if I click on sign up, look at what they offer me. I don't have to sign up the traditional way using emails and usernames and passwords and stuff. I can just click on one of these two options. I can continue with Google or with Apple. And in some cases, it's usually Facebook. Once again, we're using APIs, and Reddit will rather say, listen, I don't need to now go and create my whole user engine for this. Why don't I just use Google because they offer it to me, and I will authenticate this user against Google and streamline the process, right? That's how powerful this is. So yeah, these are examples of APIs. So once again, the benefits, the reuse of existing functionality. I explained this with Uber and Google Maps. Extended access to features and data. We are going to see this in a short while. But yes, you've been able to do a lot more than what a user interface would have allowed you to do. And finally, integration and automation. Google, Uber again, Siri. They can integrate and automate so many tasks because all they do is they can programmatically access those APIs and perform tasks on behalf of you. You do not have to go to all these websites and perform the tasks yourselves. All right. So the types of API protocols, this is as advanced as what it's going to get for your technical folk or non-technical folk. Please don't be scared, okay? This is just a little bit of buzzwords that I want to push your way, and you're going to see how this all makes sense and how most of this is almost irrelevant, okay? The types of API protocols that are available, there are many types. Some of them you actually know already. So IMAP, which is Internet Mail Access Protocol. This is what you need if you want to send mail from your smartphone to your Microsoft account or to your Gmail account. It sends via IMAP. It is a protocol that's running on your smartphone that knows how to speak to what we call email exchanges. Okay, so even though you didn't realize it was IMAP, that is a product that you were interfacing with an API protocol. File transport, which is, we know it as FTP, the ability to upload files and download files to and from some sort of central server where everyone can access these files, which is what we know as an FTP server. It is a different protocol that many use, especially in business environments, in order to centrally store data. And obviously, with a lot of innovation and a lot of cloud tools like Dropbox and OneDrive and Google Drive, FTPs are sort of becoming, sitting by the wayside, but you get the point, and many of you would have known how to work with FTPs. It was just another API layer using that file transfer protocol. But the important one, and the one that we're going to focus on today, is the HTTP protocol. HTTP stands for Hypertext Transport Protocol. It is just there so that the techies can sound awesome at the bar. And the easiest and most popular of the protocols, because it is pretty much what everyone uses in order to interact with the cloud and the internet as we know it. We also know HTTP protocols as web APIs, web services, or REST. Okay, so you could kind of use them interchangeably. There are some slight differences, but for the most part, they are the same thing. And we're going to be using the term web APIs, which refers to HTTP requests that we are going to focus on now. And the best news that I can give you right now is that what we are going to learn today to use on the DeSo blockchain, you will be able to take this knowledge and you could use it in hundreds of thousands of different places and online services and applications. This is a skill that you can take with you. It is a future-proof skill. Okay, it is a future-proof skill. So please pay attention as we now dive into the deeper parts of this live stream. So we said we're going to focus on web APIs. So let's take a typical URL. A URL is also known as a web address. All right. So let's take a look at this. First, if we take a normal web address over here, let's go to Twitter, and I click over there. We can see that Twitter's web address is https://twitter.com/home. All right, good. That is a typical URL that you would see a lot of the times whether you're doing Google search or whether you're opening up a social platform. So now let's go back to our slide and let's now deconstruct this. So the HTTP or HTTPS is what we refer to as the protocol. It tells the web engine what kind of protocol are we using in order to interface with what API. And the difference between HTTP and HTTPS is that the S stands for secure, and the traffic or anything that happens when you load and execute that API is encrypted, versus normal HTTP where everything is kind of open and transparent, which can be very dangerous if you're trying to submit credentials or very, very sensitive information. So, excuse me, you'll notice that 99% of all applications out there are using HTTPS because it costs nothing nowadays and it's very easy to set up. And if you ever do find an application that's not using HTTPS, there should be a red light. There should be a red light for you saying, listen, this can't be right. And whoever's web application is running that, they would need to kind of justify why exactly have they not secured that website. Okay, so the protocol is the beginning part, the HTTP or HTTPS. Then you've got the domain. So this is after this part, and the domain can be like a google.com or like twitter.com that we saw now, or it could even say www.facebook.com or even DeSo.org. Okay, so it's not always got to be a .com. It doesn't always have to start with a www. There are many formats of the domain, but what we do know is that it always occurs after the protocol, after the colon and 2 forward slashes, and before the next forward slash. Okay, so that will become the domain. So if I look again over here, we can see here's the protocol, here's the domain, and then there's a forward slash, and then it's the rest of the URL. So what is the rest of the URL? It is the path of the URL. Okay, so now that we know the domain and we know what protocol we're using, what we usually do is we use the path to tell the application what it is we want to load. Where is it that we want to go? So in this case, I went to the default is home. But if I wanted to go and explore stuff on the Twitter application, and I click over here, look at what happens. It now changed from home to explore. So the path of the URL, it provides additional insight to Twitter to help them understand where do you want to go when you open up our Twitter application. All right. So that's the typical structure of a URL, and that's everything that we need in order to do our examples later on. So once you got this, you're almost there. You're like 50% of the way there already. Okay. So now we're going to get to this is where we have to dive in a little bit deeper. Each HTTP request that we perform, whether we're opening up a website or whether we want to access an API from behind the scenes, each request that we perform needs to know it has to have a method type. Okay. Now there are many method types, and the two that I have over here is get and post. All right. Now what I'm going to do is I'm going to jump onto an application that you can easily download for free. If you go to, let's go over here and let's go to postman.com. I have these URLs in the notes, in the references at the end of this presentation. But Postman is an application that you install on your operating system that allows you to interface with almost any kind of web API that's out there, of thousands and thousands of applications, whether it be Twitter, whether it be Microsoft, whether it be Facebook, whether it be Dropbox. You will be able to work and interact with those applications, not via the user interfaces, but via APIs. But to make it easy for you, instead of having to write code and create these APIs, they have developed the solution called Postman, which is a visual way, ironically, It's the visual way of interfacing with these APIs. And it is the tool that I'm going to be using today. You can download and install this for free. It is compatible with pretty much every operating system. And there is no need to sign up or do anything weird. You can just download it, install it, and start using it. It's very, very simple. And what you're going to see me do today is enough for you to get going on your side. It is not an advanced tool. Okay, so postman.com. All right, so coming back to the presentation, we said now that there are certain methods that help the HTTP engine know how it must interact with the API that we're about to call. Now, I'm going to open up Postman here, and this is the interface. So don't worry about all of this. This is just the number of APIs I've already created and saved. But if I want to create a new API, if I want to test a new API, I just go ahead and click on this plus button, and it will give me this interface. Now look over here. It's saying, what is the request URL? Okay. So I can put over there HTTPS. This is mine, by the way. So I'll go api.agility.io. So protocol, domain, and then I can use the path, which is a ping. Okay. Now watch this. If I just accessed API, I will get an error back from this API. So I tried to run this now, and I got an error back that said the validation failed because I don't have the right privileges in order to just run this. However, if I change the path to ping and I ran this again, look at what I got back. Pong. So this is awesome. What's happening is I accessed Agility's API layer, and by giving the path of ping, it actually knew that I needed something specific, and it responded back to me in that fashion. So I asked for ping, it gave me a pong. Okay, so there's a couple of other things over here, but you get the basic idea. It's a request, it's a response, and you will hear that a lot. A request, response, back and forth. Okay, I ask something, it gives something back to me. But now let's get back to the methods. We spoke about how we have a get and how we have a post. Notice that the get was default over here, but if I click on this, look at all the other Look at all the other HTTP methods that are available to us. All right. Now, don't let this worry you, because 95% of the time, only these two are going to be used, a get or post. All right. And I'll explain now the difference between the two. Sometimes you do end up using these, but usually it's just a get or a post. Now, I'm going to show you something cool. Whether you know it or not, you've been running HTTP API transactions the entire time, every time you open up your browser. When we opened up Twitter, we are executing an API that tells Twitter, I want to open up this page. I need you to return to me HTML, as well as a number of other resources so that you can display it in the web browser. In this place, I'm using Brave or Chrome or Firefox, but you executed an API in order to return that data. If I to copy this now and I to go into Postman and paste what would be normally inside a browser's URL bar and run this, look at what I get back. Okay, it actually passed. It was a GET request. It was an API call. But what was returned to me is not just data, but rather HTML, because Twitter doesn't really care what you are calling it from. You're asking Twitter, I want the explore HTML, and it returned it to you. It doesn't, and there's all the resources and everything that you need in order to run this user interface right here. Okay, so you've been running a GET request this entire time, which brings me to the second part, is that the way it works in a web browser, every time you use this URL bar, if you're running it, is it running a GET or is it running a post? That would probably be one of the next questions, is how does it know if it's running a GET or a post? The answer is simple. When it comes to a browser's URL bar, it is always a GET request. It is always a GET request. It is never a post. It cannot run a post inside this bar. Okay. So that's why I said over here that the GET request is always default until you tell it specifically what method you want to use. So let's go back here to Postman and let's change this GET to a post. I must be honest, I never tested this, but this should not work. Okay, I was very surprised that worked over there. Nevertheless, it shouldn't have. If I went to api.agility.io ping and I ran a post request now, that should not work. There we go. You see. So this is actually an error saying not found. I don't know what this API is because I called a post version of this web API, not a get. My server Agility only has a get. So when I run this again, then it works. But the moment I changed it to post, my server doesn't have a post equivalent of that. All right. And once again, coming out to the browsers always work with a get request. So the post request, why is there even a post? Why is nothing ever a get? Well, the get request is when I ask Twitter for something, but I don't need to give it anything specific in order to ask for what I wanted. Okay. That is when you can just use a get. It's just Twitter says, listen, if you want to open up the homepage, you don't need to tell me exactly what it is you want to do. I don't need anything from you. Just tell me that you want to open up the homepage and then off you go. But what if I needed to be specific? What if I needed access? What if I needed to give it my credentials in order to open up or execute one's API? It's sometimes it's not as always easy as just saying, please get me this and please get me that. Sometimes we need to provide a little bit of information. And in order to do that, we need to change the method to a post on our side, okay? And that allows us now to send data to the request, but it also means that you will not be able to do it, for example, on a browser's URL bar. Now we are no longer able to do anything over here. Now we need to either go and design code or run code or use like a Windows command prompt or use a terminal or Postman, which is what we're going to use now. All right. So that's bear with me. We're going to get to the part where we actually use this. Now, when we post data, the last thing that we need to learn before we go into our live demos, when we post data, there are multiple types of data that we can send to the API system, to like Twitter as an example. And three common ones are JSON. JSON stands for JavaScript Object Notation, XML, Extensible Markup Language, and text, just plain text. Okay, these are the three types of data sets that we could send to the server. And by specifying which one it is, the server will be able to interpret that data that's coming in. Now, before this all scares you, this is very similar to a CSV file. When you create or export something to CSV, which many do often, then if you open up that CSV, 99% of the time, the CSV has got headers on top, okay? And then it's got the content underneath, and everything is separated by commas, and everything is a row on its own. But the first row is usually the headers, the column headers, okay? Well, with JSON and XML and, well, not necessarily text, but with JSON and XML, it really works in a similar fashion. And let me show you, let me give you an example of what JSON looks like. Any JSON schema that gets used for sending data will start and end with an open curly and a closed curly. It's just the default, okay? Any JSON, if you want to send data, it must begin and end with curly brackets. But then inside there, you will provide the column name, colon, and the value. So if this was the CSV, if this was now CSV equivalent, the first row would have name, comma, age, comma, level, comma, gender, comma, status, and then underneath it, it will have the value for name, and the comma, the value for age, and so on and so forth. All that we're doing here is it's being presented in a different way, where the curly brackets represent the one row, and instead of having a column on top, you actually have what we call a property name that defines the property for this. So we know this is a name, this is an age, this is a level, this is a gender, this is a status. Now, why not use CSV? Why go this route of JSON? And the answer is JSON data, in this case, is extremely, extremely lightweight. And when you're interfacing with APIs, it is so important to keep the amount of data that gets sent and received as small as possible. So the XML equivalent of this would be a lot bigger, and the size of the data that you would land up sending or receiving in XML would be way larger and would land up costing you mobile data or land up congesting network traffic at a company. There's so many reasons why you want to keep the data as minimal as possible. And JSON is just one of those data formats that allows this to happen. But secondly, JSON allows you to create so many different kinds of values. So you can, it's much more understandable. Not everything is just a string or a number. You can actually, the systems, Twitter can understand a lot more about your data than what it could if you had passed it CSV as an example. And you can also drill down deep and you can create multi-tiered relationships in your JSON data, which is very, very difficult to pull off when you're working with CSV files. So these are just some of the quick examples and reasons why JSON would exist in the first place. And even though we've got others like XML and text, you will find when you play around with APIs that JSON is lightweight and the most popular to use. So it really is worth the time, and it gets used absolutely everywhere. It is a future-proof skill. It gets used on so many platforms in so many different circumstances, and it's going to be the case for many, many, many years to come. And the best part is it is so easy to learn. You just got to spend a few hours acquainting yourself with it, and before you know it, you know how JSON works. Now that we understand the structure of an HTTP URL and the methods that we are going to use, we now want to start speaking to the DeSo blockchain. All right. Now, how do we do this? So first, we need to understand, in order to interface with the DeSo blockchain, we need to know how is its API URL structured. Okay. And that's what this slide is for. So we can see the protocol is https://. Good. Then we see that the domain is node.deso.org. And then the path would be something /API, whatever. But I showed you here just as an example of what the path could be. Okay. So that's our structure over here for the DeSo API URL. Now that we know this, we can now go and use Postman and start populating some of the information over here. So I can go, let's close this and let's start a new window over here. And I'm going to do what that slide said, https://node.deso.org/. Okay, so I've got the protocol and the domain out the way. But now, what path do we use? How do we know what we want to do? And this is where the documentation is important. So if I go over here to DeSo's user documentation, you can see that I am now in the section of blockchain data, and I'm under API and I'm under user endpoints. Wonderful. Look at all these endpoints that are over here. And those that are already on any kind of social media platform, more importantly, the DeSo platform will understand how this will all work. So we've got some APIs that we can call. We can get users stateless, okay? We can get profiles. We can get a single profile, a profile's picture, as well as a couple of other things. So we can, I'm zoomed out over here. So get the user global metadata, email, phone number, updates their data, and a couple of other things, okay? So we've got a few things that are connected to a user endpoint over here, and then we can see, but it's categorized, right? So if I go to post endpoints, now we can get things like get a post, get the hot feed, get diamonded posts, get likes for a post. And there's a whole bunch of APIs that are available to us that allow us to go and find particular information that sits on this DeSo blockchain, allowing us to go and fetch specifics. So that's so exciting. That's so awesome. All right. So, and there's a number of other things. Look at this, NFT endpoints. How many of you have ever worked on Web3 on blockchains where you have to know Solidity in order to set up and create your own NFTs? Obviously, there's ways to do it via OpenSea, but you get my point. If you wanted to create your own custom NFTs, you have to sort of learn a new programming language, and you have to work on completely different platforms in order to deploy it. Whereas over here with DeSo, these are web APIs. You can get NFTs, but you can also create NFTs. I just don't know where it is. It's here somewhere. It's under a different category. I think it's under transactions. There's a transaction section as well. Anyways, so over here, we have everything that we need to do all kinds of crazy stuff on the DeSo blockchain. But what we're going to do is we're going to jump to this and let's do a first one here. Let's get the person's single profile. All right. Because as soon as I used mine, we can actually use this. So if I click on this, over here, you'll see it opened it up on top. And if I expand this documentation shows me, gets information about a single profile. the endpoint and examples of its use, but yeah, are its parameters. All right, so here's the first thing. Look at this. This is the path. It's not showing me the protocol. It's not showing me the domain. That is assumed. We know what it is. This is just showing the path because the protocol and domain will always stay the same. Okay, so the path over here says /API, the version of the API, which is version 0, and then get single profile. Now, if I go back to this over here, I can say API version 0, get single profile. There it is. Okay, so there's the URL. But what else is the documentation telling us? It is telling us what method to use. So if you're ever worried about how will I know if I need to use a get or I need to use a post, it is the platform's documentation that will tell you exactly what you need to know. Okay, so we now know we can choose a post. And then finally, the body parameters. So it says over here that there are 3 parameters that we can add to the body. Now, what they're not telling you and what you kind of figure out is that the body, the data in the body must be sent in JSON format, which is exactly why I took the time to just quickly get you acquainted with what JSON is. We are going to be sending this over here. Okay, so if I go back to Postman, I can go to the body and I can go and choose, well, they don't have it as an option, but there, I can choose raw and JSON. So that's what I want to do over here. And this is the JSON body. And what did we say earlier on? Anything that would be sent as JSON needs to have an open and close curly bracket. Okay, cool. So now we know that that's the first rule. And if we go back to this, we can see that the property name must be in double quotes and the property name and the value must be separated by a colon. And for every new property values, we have to use a comma. Okay, basic things. You learn it within your first 5 minutes of learning JSON. So don't let this overwhelm you. But let's go back to the documentation here. For them, they're saying, please, if we want to see a user's profile, we can't just send this. It's not going to work. If I go and send this now, it's not going to do anything. It's 404 not found. And look at the error that's returned. It's quite helpful. Get single profile. Could not find profile for username or public key. We never provided any. Okay, so this is what's important. This is why we had to change it to a post. We needed to send information. Now let's take a look at what their rules are, the body parameters. We can either use this here, which is the public key of the profile to fetch. Okay, I know what that is. And it says over here, username. It is the username of the profile to fetch. Required if public key is not provided, and vice versa over here. This is required if the username is not provided. So they're giving you an option. Do you want to use the person's username or their public key in order to fetch their user profile? And then there's just another optional over here where it says, if there's nothing, do not throw an error message. Don't worry about that. They're just saying there's additional things you can do that we could provide you a little bit more sort of seamless means of integrating. But we are going to just go with the username for now. So we need this username as a property. And please be careful. It's case sensitive. So I can't say username and leave it lowercase. It's an uppercase value according to the docs. Okay, so that's number one. And we know that the prop name and prop value must be separated by a colon. And now we need the value. So what is my username? I want to go and fetch my user profile. What is my username? I can go to DeSocial World and I can go to my profile and my username is John Jardin. Okay. Yeah. And type that in as my username. And if I click on this now, look at what we had just done. We have just retrieved my public user profile from the DeSo blockchain. Okay, that's what we have done. Look at this. Here's my public key. That's what it was asking for in case you didn't have the username. There's my username. There's my description, CEO, founder of Metability and Agility. If I go back to this, look at what it's saying there. CEO, founder of Metability and Agility. And it's giving me all this information right here in this data. Look at what it's doing. It's giving me additional information. For example, am I verified? Unfortunately not. The coin entry. This is the coin. Every user account on the DeSo platform has their own token, and you have your own tokenomics as well. So this gives you information about how many people have bought my coin, what the locked value is, and a couple of other things. It also sees if I have any DAO coins or if I've set up any DAOs, and it's providing me a number of additional bits of information that I don't see when I open up my user profile on the user interface. And this comes back to what I said earlier on. What are the cons of a user interface? They're not showing you exactly what you can actually do on the platform. They are only giving you what you will most likely want to do on the platform. And if you want to do anything more advanced, you have to interact with the APIs instead. Okay. So now, question, can I only retrieve my user profile? Well, remember what I said. This is the DeSo blockchain, and the answer is you can retrieve anyone's public user profile, not just mine. Okay, so not just your own. Notice when I called this request over here, other than telling it what the username of the profile is that I wanted, where else did I tell it who I was? It doesn't know who I am. It has no idea who I am. This is what we call an anonymous transaction. Okay, I am anonymous until I've actually authenticated in some way. And until then, I am anonymous. That is how DeSo has seen me now when I try to perform this request. So to give you an example, I'm going to go and grab someone else's user account. So I know that I've got OmniFrog. I've got OmniFrog in one of the sessions over here on Entra. So I'm going to use his. I hope he doesn't mind. So there we go. I'm just grabbing his username. I'm going to copy it. We can see this is his user profile. And if I go back here and I replace the username with his and I click on send, there we go. Username everywhere and everything exactly as what he's saying over here. Plus, I get to see a number of additional things about his token, as well as his DAO entries, as well as a couple of extra things that weren't available over here on the user interface. Okay, so this is such a great start, and you can go ahead and do exactly what I'm showing you now. Just go grab people's user profiles and go and see what it is, what their user profiles are. Now, unfortunately, remember, this is a post request. So could I run this on the browser? And just to show you once again, there's no ways that this should actually work because a browser forces a GET request. Okay, so you can see how this is not working anymore. And why? Think about it. How am I supposed to tell it? How am I supposed to send it this port? Where am I supposed to send it in the web browser? There's no place here. Okay, so this is why this is always a GET request, and anything that's not a GET request cannot be executed over there. So let's go find a GET request. I want to do two more. I want to show two more APIs. So let's go find another one. So we did the get single profile. So we know the method is post, get single profile, the body is JSON. Okay. Get single profile picture. This is a separate API. Okay. Get the person's profile picture. All right. Now this method is a get. It's not a post. And this is the path to that API call. If we go to the actual documents, this is what we are going to go and get here. Get single profile picture. If I expand it, it is a get request. This is the path, and look what needs to be added into the path. If we just added only this part, if we only added this, whose profile pic are we getting? Remember, a GET request doesn't have body data, okay? So I'm going to now go and add a new one. I'm going to right click here and I'm going to say duplicate this tab. I'm going to choose a GET request, and I'm going to just change this to get single profile picture, okay? Picture. Here we go. Now, what we need to do is we need to provide the user's public key. Notice they don't ask you for the username, okay? Sometimes you're lucky and they give you the username, but sometimes you have to provide the actual public key. And I'll need to go here, go to my wallet, and my wallet, there's my public key. I can click on copy. This is not a safety issue, me showing you this. This is a public key. The best thing that you can do over here is view my data and send me money. All right, so I'm going to go over here and I'm going to paste this public key, and there's no more body data. I'm going to choose here none. There's nothing. And if I run and I send this, look at what I get back. There's my profile picture. Okay, there's my profile picture from the DeSo blockchain. And this is how the other applications, when I showed earlier on that I went on to Overcloud's got my user profile and my username. And I went on to, where is it? Entra, there's my user profile on Entra. Okay. And it's doing this because it can fetch this data. They're interfacing with the APIs. It's brilliant. Okay. It's not, they're not talking to each other. They don't know who each other are. Entra doesn't actually know who DeSocial World or who Overcloud is. They know who the blockchain, the DeSo blockchain is. Okay, so we've got that over there. But now, because this is a GET request, I'm having fun with this, everyone. Because this is a GET request, doesn't this mean that we could run this in a web browser and it would kind of give us the same thing? Absolutely. If I go into Firefox and I go and override this and I paste that, look at what I get back. Even on a web browser. And remember, a web browser knows and communicates using APIs. We just think of it as opening up web pages. So this is the power of understanding what web APIs are. All right, we're going to do a final example here, something that might be more meaningful than just getting a person's user profile. We are going to go and get the hot feed from the DeSo blockchain. Okay, so what is the hot feed? If I go to DeSocial World, well, I suppose they're using something else, but you see this tab over here. This is the hot feed tab. And if I refresh this, it should update. If I go to Overcloud and I go to Overcloud's homepage, they've got a hot feed tab. Okay, so we can fetch this hot feed programmatically using DeSo's APIs, and that's exactly what we're going to do now. So where are we? I think it's post endpoints. There we go, get hot feed. I'm going to click on that. I'm going to expand this so that I can understand the details of what is required in order to get the hot feed. So we know that it's a post request, and we know that the path will be get-hot-feed. All right, let's go do that so long. So I will go and duplicate. I'm going to duplicate this, and I'm going to change this to a post. And I'm also going to change this. We don't need this part anymore. So I'm just say get hot feed. Okay, so there's the URL, the protocol, domain, and path, and it's a post request. And in the body, we want JSON again. So we go to raw and we go to JSON. And we know that we have to open and close JSON with curly brackets. Now let's go and find out what they want inside here. None of these are compulsory. Usually they show you that it's required. They would usually have like a red asterisk or they would have like a term or something that they absolutely need in order for you to use this. But I see none of these are compulsory. I could actually bypass all of these and just see if it will return me a hot feed. But I've done this already. And for the sake of this webinar, I know that it will return me a lot of data. And even though it works, I wouldn't have to send anything. It will return a copious amount of data, and we'll be sitting for the next few minutes waiting for it to run. So what I am going to do is I'm not going to worry about the public key or scene posts, but I'm just going to say limit it to whatever, to 10 records. That's all I'm going to do here. So the response limit is a number value of number of posts to fetch. Let's go and see how this would work over here. Response limit, okay. We use a colon to separate the property name from the value, and it says the number of posts to fetch, we want 10. Now, earlier on, we were putting username values and everything in double quotes, representing a string, a text value. But look at what they do here. They will tell you if it's a string value or if it's a number value. This is a unsigned integer. Okay, it's a little bit, sorry, that was a little bit techie, but this means it's a number value. So if it doesn't say string or boolean, it's a good chance that that it's a number value. So I'm not going to put this inside double quotes, and instead it's going to be a number value, as you can see it here. Now, if I run this hot feed, it should run perfectly. There we go. We can see that this is how long it took, and here's our hot feed page. So what we're looking at now is we're looking at the post content that exists inside these hot feeds. If I go over here, we're looking at the post content that is coming through onto this hot feed, except that we are seeing it in JSON format programmatically, and we are seeing a lot more than what the user interface is showing us. And it's a little bit tricky because, yeah, there's a number of records that are being returned here, and I'm only telling it to return 10, and the application might be sorting it. So I'm not too sure if we will find the post we're looking for, but let's take a chance. Okay, that's the body, day 42. Over here, anything? Ah, look at that. There we go, on the hot feed, day 424. Oh, sorry, you're right. Yeah. So look, this is the entire body for this post. We are actually seeing this post with the video, with the YouTube link. We've seen it right over here. It's giving us everything that we need. And I want to see, look at the like count. The like count is 32. The comments are 13. Oh, sorry, the comments are 7 and the reposts are 13. The like count is 32. The diamond count is 33. There we go. Diamond count is 33. So do you see how great this is? You could extract this information from the DeSo blockchain, and you could now go and create your own analytical reports to try and understand what trends are occurring, what people are talking about. You now have the power to go and perform these analytical transactions against the DeSo blockchain and just take complete full advantage. This is what Twitter used to do with your Twitter data. It used to use this, same with Facebook, same with whoever else. They would use these kind of APIs against this data, and they would go and determine what trends are occurring. They would be in control of how this all works. But the DeSo blockchain has given us the power to go and do this. There is no centralized authority or single entity that has control over this data. All right. So I've given you enough for you to be able to go and work on the rest of the APIs that are available to you and allow you to go and just have all kinds of crazy fun. There should be no reason why you get stuck with anything that was shown inside this live stream today. I've got a bunch of reference links over here. Here are the 3 Web3 applications that interface with DeSo that I was demonstrating today and that I'm streaming to right now live. Here is the DeSo Essentials course on my Web3 Simplified YouTube channel. And here is a link to the Postman application, which I used to perform all of these tests with. Here are my contact details. If you're on DeSo, I'm at John Jardin. On Twitter, I'm at John Jardin Codes. And here is the URL to my Bleeding Code YouTube channel. This is where I do all kinds of development tutorials, best practices, and there's a lot of Node.js, React, and a lot of integration and APIs. And most importantly, blockchain Web3 types of tutorials will be loaded on that YouTube channel, whereas Web3 Simplified is focused on really trying to keep the Web3 ecosystem, NFTs, metaverse, crypto, Web3 applications. My goal is to simplify it so that it can be adopted by general users and not only by technical people. So because everyone should be on these platforms, it is just too exciting for it to only be for technical people.
You know, in social media, we are having so many advertisings and all going on. Is it the DeSo, all right, Web3 will be in that level in future, like with a lot of, advertisements and all those stuffs?
No one can really stop anyone from advertising. Okay. But here's the kicker, yes? And you're actually asking a very, very good question. This is a great question. So you can still see my screen.
Yeah.
So now what we're worried about is even on, like, DeSocial World is pure Web3. Okay. DeSocial World is fully exists on the DeSo blockchain. It's a pure Web3. But can someone come and start advertising here in the feed? Okay.
All right.
Even if it's a Web3. And the answer is yes, but not because the DeSo blockchain allowed it. It was because DeSocial World themselves decided that they want to allow advertisers to advertise on the feed. It's got nothing to do with DeSo themselves. They would not promote advertising. It's got nothing to do with them. They just provide the architecture. So yeah. So, and that is why, and this is, so you think to yourself, okay, maybe DeSocial World would do that. And maybe they get away with it for a little while. But guess what? When people get annoyed with it, where are they going to go to? They're just going to open up Overcloud instead of DeSocial World, and they've still got their posts. They've still got their user profile. They didn't have to register a new account. They just carry on Overcloud where they left off on DeSocial World. That is how powerful this platform is.